Hello, I'm Greg Walensky, and this is going to be my AP Calculus AB project for the third trimester. And recently I moved to Tenafly, and I wanted to find a walking path for myself. And of course, I needed the exact length of that path, otherwise, how could I possibly walk it? And also, this was an assignment, so that provided just the encouragement I needed to find the length of that path. Um, and on this picture, you can see my actual path. So it's just, I believe it's located right around the center of Tenafly, and it's a pretty long walking path, about 3 miles, actually. And on this next picture, you could see how I divided the path into many, many different parts, so it would be easier for me to find the length of it, and then each of those pieces I later graphed and found the length of that piece. So here on this slide, you can see all of the different graphs I had just smashed into one page. And on this page, you could see all the points graphed onto one graph, and you could see that it kind of resembles the shape of the path. So I did consider that a success. It does look a lot like the path. And now here I have my sample calculation for the first graph, graph A, and this is a linear graph. So all I did was use the Pythagorean theorem. So x squared plus y squared equals z squared, and the points on this graph were 0, 0, and 0 0.464, 0 0.228. So to find its length, I simply did 0.464 squared plus 0.228 squared equals 0.267. And that's z squared, so you have to take the square root of that, and you get 0.517 miles. And that's the long part on the top, that's why it is so long. And here you can see just graph A, just so you understand which graph I was referring to. And here's my second sample calculation for graph C. And this one I actually have to use our formula, so the formula of this graph was y equals 50.796 x squared minus 55.813x plus 15.311, and it goes from x equals 0.49 to x equals 0.562. The arc length formula is L is the integral from b to a of the square root of 1 plus the absolute value of the derivative of f of x squared dx. So in this case, plugging in the numbers, I got the integral from 0.562 to 0.49 of the square root of 1 plus 55.813 minus 101.592 x squared dx. And remember that last part is just the derivative of that formula I gave you before, and that is equal to approximately 0.209 miles. So here you can see the graph of C, and you can look at the axes. The x-axis is the distance in the x direction in miles, and the y-axis is the distance in the y direction, also in miles. And on this next slide, you can see the table of each and every graph that I had labeled A through U, and the corresponding length, and then the overall calculated length, which is 3.27 miles, and the actual length, which is 3.07 miles. So overall, pretty close together, and just to get more of a mathematical sense of how close or far apart these two values are, I calculated the percent error, which can be seen here on this slide. So percent error is the absolute value of accepted minus measured divided by the accepted value multiplied by 100 to get the percentage. And in this case, after that calculation is done, it is evident that there is a 6.5% error in this activity. So a relatively small percent error. And I guess that concludes this project. I will now know exactly how much I am walking when I walk in the mornings. So thank you.